Hello, good morning students. I am Dr. Sunita Tandon from RR College Alwar. Today I am going to deliver lecture number 8, that is relation between oscillation reactions and autocatalysis, or we can say we are studying Zhobotinski reaction, or it is famously known as BZ reaction. In the last lecture we have studied about oscillatory reactions, there which we have seen that these type of reactions require an induction period, and after they get a increase in the concentration, and we have got a inflection point too. The presence of one or more autolytic steps in a complex chemical mechanism can lead to the phenomenon which is chemical oscillation. I want to say the presence of one or more autocatalytic steps in a complex chemical reaction mechanism can lead to the phenomenon which is known as chemical oscillation. Normally, chemical system approach equation in a smooth, frequently exponential relation under special circumstances. However, the concentration can oscillate between several stationary states, or by analogy with electrical or electro-optical systems that display oscillations or stability. Such systems are described sometimes as, for example, of chemical feedback in addition to temporal oscillation. These systems can also provide non-uniform spatial structures, which appears to arise spontaneously from a homogeneous medium. Chemical oscillation is rather usual. The phenomenon has been of much vigilance or significance in a biological system. Introduction. The reaction is very complicated reaction which remains unexploited for a longer period so far as its mechanistic steps are concerned. In 1959, Zhobotinski introduced the cerium-3 catalyzed oxidation of malonic acid HMA by bromate ions BrO3 in sulfuric acid medium. Later, in 1968, Zhobotinski showed that if the reaction mixture left unstirred, spatial periodical variations of intermediate concentration can also occur. He determined that instead of cerium-3, weak equal reductant like Mn2 and iron-2 can also be used. The reaction called as BZ reaction and can be represented as 2 BrO3 bromate ions plus 2 H ions acidic medium plus 3 malonic acid molecules HMA, that is CH2 in bracket CH2 whole twice, COOH whole twice. In presence of cerium-3 and bromide ion, they turn into BrCHCOOH2. This is bromine malonic acid. 2 bromine molecules are added in this reaction. One molecule, the 2 molecules are formed in a reaction and 1 bromine atom is introduced, plus 3 CO2 plus water, or 3 BrO3 plus 3 H ions plus 5 CH2COOH malonic acid. They give cerium-3 and bromide ion to form 3 BrCHCOOH whole twice, means bromine malonic acid plus 4 CO2 plus 5 water plus 2 formic acid molecules. Instead of malonic acid, we can also use bromomalonic acid. Malonic acid which are easily brominated by bromine in this reaction. Mechanism of BZ reaction. Fine and Noyes have proposed that the mechanism involving three distinct intermediates capable of undergoing coupled oscillations. First is HbRO2, that is bromous acid, is an intermediate whose concentration changes between two limits. Second is bromide passes through a critical value. Okay, second intermediate is bromide ion which passes through a critical value. And third C is cerium 4 is an intermediate which generate bromide radicals. The oscillation arises because of switching from one reaction sequence to the other as shown below. First of all, we see the first species which is formed is HbRO2. It is an intermediate. This HbRO2, at low concentration bromine, presence of cerium 3, BrO3, sequence B undergoes a sequence B and forms cerium 4 and HbRO2 are again generated. This cerium 4 in presence of bromine malonic acid, this is sequence C, is converted into cerium 3. This is sequence 3. Just see the three options above. Then insufficient quantity bromine is present in critical value. Then again it is converted into BrO3. BrO3 by reduction again form HbRO2, and this HbRO2 gives high concentration of bromine and form HOBr. This HOBr formed then react with sequence A, in the sequence A with malonic acid to form bromine malonic acid. Schematic line diagram of BZ reaction above schematic diagram shows the systematic diagram of BZ reaction. Schematic line diagram of BZ reaction above reaction mechanism based on origonator model to account of the oscillation behavior. The series of elementary reactions broken down into three groups A, B and C. Sequence A. When solution contains sufficient amount of bromide ions, the reduction of BrO3 and bromination of HMA malonic acid by HOBr occurs. First step में 2H ions they combine with BrO3 plus bromide ion with rate constant of K1 and form HbRO2 plus HOBr. Second reaction is H ion combined with HbRO2 formed in first step and bromide ions with rate constant K2, that is slow, so it is rate determining step, and forms 2HOBr. Reaction 1 and 2 coupled with two rapid reactions 3 and 4. Third reaction is bromide ion react with HOBr plus H ion with rate constant of K3 gives bromine and water. In fourth step, bromine react with malonic acid CH2COH with rate constant of K4 to form BrCHCOH whole twice plus H ion plus bromine malonic acid. Two overall reaction, first plus second plus third plus fourth constitute the sequence A lead to bromination of HMA as follows. BrO3 plus 2Br plus 3H ions plus 3CH2COO whole twice. It will give you 3BrCHCOO2 bromine malonic acid plus 3 water, and this is the sequence A. Sequence B, cerium 3 is charged in cerium 4 is changed in cerium 4, bromide ions fall below the critical value. So the reaction between HbRO and BrO3 become more faster than between HbRO2 and bromine free radical. In next step, BrO3 negative form react with HbRO2 plus H ion, and with a rate constant of K5 with a slow reaction, it gives 2BrHO plus H2O. In the next step, H ion plus BrO2 ions combine with cerium-3 with rate constant of K6 and is converted into HbRO2 plus cerium-4. Disproportionation of HbRO2. 2HbRO2 with rate constant 7 change into BrO3 plus HOBr plus H ions. Thank you. Rest of this sequence B and C we will study in next lecture, that is lecture number 9.